Scalability and elasticity. Scalability talks more about the longer term, meaning over the longer term, over months, over weeks, over years, our system gets used more and more. So we need to employ some methods in order to scale the system. While when we talk about elasticity, we talk about the ability of the system to increase its resources and to decrease its resources to be able to handle different types of traffic, which can be during the same day. So if over the day we have high traffic, we would allow the system to get more resources dynamically, and overnight to remove resources in order to save money. Also, we have databases that support this internally. It's like pay for the resources that you consume versus get specific allocation of resources and use them. So elasticity does not necessarily mean automatic allocation and deallocation of resources. We did not mention here anything about automatically allocating or deallocating resources in elasticity. All elasticity means is that the system is able to increase its resources. This can be done manually, and this can be done automatically. And of course, we would prefer the elasticity of the system to be able to allocate resources automatically over the day when we get more traffic to allocate more resources, and over the night when we get less traffic to allocate less resources. Scalability means it's like a different scale. It's as the name says, scalability. The scale of the system needs to change, and we can do this with two major methods. One is the vertical scaling of the system, and two is the horizontal scaling of the system. So we should not take into granted that today we just scale it horizontally. This is what we prefer, because horizontal scaling has some disadvantages. It's complicated. When we get more services into the system, we need to discover them. We need mechanism for the discovery of the components. We now have remote communication between the components. We need to load balance in between the components. We need to monitor the different components. We need to track them. We need to scale them separately. So horizontal scaling, it sounds simple, yeah? I just add more machines. So no, it's not that simple. Okay, we need to load balance between the machines, and we need to handle the machine itself. The machine themselves can have failures. This is why we actually prefer to start with vertical scaling. First, start by checking whether the code is inefficient, right? If the code is inefficient, we could make it more efficient, of course, if we keep it still readable. So this is vertical scaling. We take the same machines, we take the same code base, we take the same project, and we scale it vertically. Of course, this has the problem that it's limited. I mean, if it wasn't limited, we could have the whole internet in one laptop, but it's and then just increase and increase and increase the size of this laptop, make it a supercomputer. But this is not the way things works, because it's limited. It's limited how much optimizations we can do in software, and it's limited how much memory we can add. But this is a great start. We can go a very long way with vertical scaling, and this would mean years. For years, we can scale some things for companies in vertical scaling. And only when we approach the point where we cannot scale it anymore vertically, then we should start thinking about the horizontal scaling. This is a rule of thumb. And of course, the 80%, 20% rule also apply here. This does not mean that all the time we should do vertical scaling. We can also start with horizontal scaling. But if we take, for example, databases, then the cost of moving from vertical scaling to horizontal scaling may be a super high cost. We may move from a relational database into a non-relational database. And we really need to ask ourselves, do we really need to move from a relational database to a non-relational database to support scalability? Because maybe with vertical scaling of the current existing database, we can still go a long way, and relational database have super strengths. I mean, they're here for 40, 50 years, stable, consistent. Everybody knows how to write the SQL to them. So these are great databases, and we should vertical scale them. Of course, this is opinionated. I mean, you can start by doing things horizontal scaling, and it depends and it varies from a company to company and from which product you work, but this at least consider, okay? At least consider first vertical scaling before going the horizontal way, because also the horizontal scaling has its issues. It's having a lot of issues, the horizontal scaling, and we need to handle them. It adds super complexity. The system becomes super complexible. Also, in vertical scaling, we can think that if the node of the vertical, the single node fails, then we don't have any availability. But no, that's not true, because we can have multiple processes inside the single node, and we can also make sure that we have an available system. So this was in general about scalability. This is more of the long term. This was about elasticity, which is more of the short term, the elasticity of the system to respond to different traffics, and the pros and cons of vertical and horizontal scaling, when to choose each, and in general.